Now my next question is, let A1, A2, A3 be a GP of increasing positive numbers. Let the sum of its sixth and eighth term be 2. Sum of sixth term, that is A6 plus A8 is equal to 2. And the product of A3 into A5 is equal to 1 by 9. This is given to you and you have to find the value of this. So this is a very easy question for uh, higher secondary student. This is a very easy question. You have to find out the value of A and R because it is in GP. If you can find out the value of A and R, then you can easily find out the value of A2, A4, A6 and you place here, you will get the answer. So here you see that you will get the answer. So here you see that A6 plus 8, A8. So A plus, this A6 is AR to the power of 5 plus AR to the power of 7 is equal to 2. And here your AR to the power of 2 into AR to the power of 4 is equal to 1 by 9. So this is A square R to the power of 6 is equal to 1 by 9. So AR cube the whole square is equal to 1 by 9. So AR cube is equal to 1 by 3. So here you see that you got the value of AR cube. Now again you see here that is AR5 plus AR7. So AR5 plus AR7 is equal to 2. So here you can take it is better to take AR to power of 3 common. So it will be R2 plus R4 is equal to 2 and this value is 1 by 3. So 1 by 3 R4 plus R square is equal to 2. R4 plus R square is equal to 6. So R4 plus R square minus 6 equal to 0. So R4 plus 3R square minus 2R square minus 6 is equal to 0. R square common R square plus 3 minus 2 R square plus 3 is equal to 0. So R square minus 2 and R square plus 3 is equal to 0. So your R square is equal to 2. Because R square equal to minus 3 is not possible. So R square is equal to 2. You have got this answer. Now again here AR into R square is equal to 1 by 3. So AR into 2 is equal to 1 by 3. So AR is equal to 1 by 6. So this is one result, this is one result and this is one result. Now you have to find out the value of this. So this will be 6 A2 AR, A4 AR cube and this A4 AR cube, A6 AR 5. So here you find that 6 here AR is common, 1 plus R square, and here again AR cube is common, 1 plus R square. Now here you see that you know the value of everything, that is 6 into 1 by 6, 1 plus R square value is 2, AR cube its value is 1 by 3 and 1 plus this is how much? R square is 2. So this is 3 into 1 by 3 into 3. So your answer is 3. This is your answer. So you see here that this was a very easy question, not a tough question. It was within your class 12 level. This 11 student can easily solve this question. So this is the answer. R square is 2, AR is 1 by 6, AR cube is 1 by 3 and 1 plus 2, so 3, 3. Here your this cancels out. 1, so this is 3, 1 by 3, so 3, 3. This is your answer. Now you see these three questions. One came in 2023, one came in 2022, one came in 2020. These three are the similar questions. You have to proceed in a similar way. But I am going to do the first one for you. What I want to tell you that it requires little bit of practice and little bit of PYQ questions if you deal all the PYQ questions, and at the same time you have to do the graduation pass course. You have to do the syllabus of the graduation pass course. Then I think so to crack JEE mains is not so tough. So after all, here you see I'm going to solve this first one. Now, if you look in this is a very important and interesting question. If you look here, x 1, I'm writing it like this: 1 plus x to the power of 49 x plus uh, hmm, okay, 1 plus x to the power of 499 into x square, and this goes on to x to the power of 500. It looks as if uh, it's a binomial theorem. It looks as if, because you can consider this as NC naught NC 1, again here this as here you see a to the power of n, a to the power of n minus 1 into x, nc2 a to the power of n minus 2 into x square, and at last ncn x to the power of n. It looks as if it is in binomial theorem. It looks as if it is in binomial theorem, but it is not in binomial theorem. You see the get up of this question. It looks as if it is a binomial question, but it is not a binomial question. Here, this is not a binomial question. This is not a binomial question. So here, what I am going to do is that 1 plus x to the power of 500, I am going to take common. So this will be 1 plus x by 1 plus x. Now here, this is 8. So here again, x square by 1 plus x square, x cubed by 1 plus x square, sorry, oh no, x the whole square. This will be 1 plus x the whole square, 1 plus x the whole cube, and this will go on to plus x to the power of 500 by 1 plus x to the power of 500. Yes. Now here you see this series is in GP. So this will be 1 plus x to the power of the whole 500, that is a is your 1. Common ratio is x by 1 minus x by 1 plus x to the power of 500 terms, 501, because from 1 it is 500, from here it is 501. Then again 1 minus x by 1 plus x, a minus r to the power of n by 1 minus r. So here now you have to solve it. So here you find that this will be here 1 plus x to the power of 500, and this again this will be 1 minus x to the power of, keep a gap between here, it will be better if we keep a gap here. So let me do one thing. Acha, later on I will rub it first of all. So here this will be how much? 1 plus x to the power of 500, and here this will be 1 minus x to the power of 501 by 1 plus x to the power of 501 by 1 plus x minus x, so this will be 1 by 1 plus x. So now because it is 500, so plus 1, from here it starts. So this is 1, 500, so this is 501. So now what you find here, if you take LCM here, this will be how much? 1 plus x to the power of 500, this will be 1 plus x to the power of 501 minus x to the power of 501 by this will come down, and this 1 plus x will go up, so this will be 1 plus x to the power of 500. Yes, here, this. So here this and this cancels out. The only result left with you is 1 plus x to the power of 501 minus x to the power of 501. This is the only result which is left with you. So now we are going to expand it by the binomial theorem. Here now we are going to expand it by binomial theorem. Now when we expand this with binomial theorem, this will be 501 C naught 1 plus 501 C1 C1 x to the power of 1 plus 5 naught 1 C2 x squared. This will move on, and then we come to plus 501 C500, that will be x to the power of 500 plus 501 C501 501 x to the power of 501 and minus x to the power of 501. So this and this terms cancels out. The only term remaining left here is this. This is the only term remaining. It is left here. So from this we find that we have to find the coefficient of x to the power of 301. So this will be how much? X to the power of 301. So 501 C 301 x to the power of 301. So this comes out to be, so your coefficient will be 501 C 301. This is your answer. So see the pattern of this question. It looks as if it is a binomial theorem, but it is based on binomial theorem, but it is not based in binomial theorem. It is in GP, and for the final calculation you have to take the help of binomial theorem. Here you have to take the help of binomial theorem. Now my next question is this. Such type of questions, the procedure which I am going to adopt here, such type of procedure, again I am going to tell you that in advanced maths, your SEBA class 9, you have done such type of questions. Class 9 advanced maths, you have done such type of question. Here what we are going to do is that we are going to find the nth term. Nth term, this will be 1 by this 2n plus 1 the whole square minus 1. This will be the nth term. You see, you place here 1 or 2n minus 1. You 2n plus 1. You place here 1, so 2 plus 1 3. You place here 2, 4 plus 1 5. You place here 3, 6 plus 1 7. So this is the nth term. Such type of first of all you find out the nth term, then you find out a1 a2, then you sum it up. Such type of questions you have done in advanced maths in SEBA in for class 9. You have done this. So what I am going to do here, so here this will be equal to 1 by 4n square plus 4n plus 1 minus 1. So this will be 1 by 4n square plus 4n. Now your an will be 1 by 2n plus 2. Now we'll make an adjustment. This will be 1 by 2n. Before that, we are going to do one thing. An, that is equal to 1 by 2. This will be 1 by 2n minus 1 by 2n plus 2. So here result will be 2, 2 cancels out, and this will be 1 by 2n plus 1. So your a1 will be 1 by 2, 1 by 2 minus 1 by 4. Similarly a2, 1 by 2, this will be 1 by 4 minus 1 by 6. Similarly here it will go on, and a last is your 201. So 201, that will be 1 by 2, 1 by 201 minus 1 by 201. That means 201 into 2, that will be 402 plus 2, that is 404. This will be 404 because your this term is a1 a2, sorry 1 minute, it will go on, 1 minute, it will go on like this, not a200, a1 a2, you have to get 201. That means 99 into 2, 2 nines are 18, 2 nines are 18, 119 plus 1. So this will be 200, 100, 101. 101, 1 2 3 4 5 6, it will go to 100, 101. That means how you are going to get 101. That means how will you get 101? So here you see your last term is this 201. So 100 into 2, 200 plus 1. So this will be, your last term will be a 200. So this will be 1 by 2, 1 by 200 minus 1 by 202. Not 200, a 100, sorry, a 100. Your a 100 will be this term, a 100, because 2 into 100, that is 200 plus 1, 200 plus 1 square minus 1 this. So when you add up this all, when you add up, you will get Sn 1 by 2. What will happen? You see, this term like this is cancel out. So the only term will be 1 by 2 minus 1 by 202. This will be. The only term left will be this one. So your Sn will be equal to 1 by 2. That is 202 is your LCM. So 101 minus 1. So this will be 150 by 202. So 25 by 101. So this will be 25 by 101. This will be your answer. So you see here, So you see here that such type of questions you have done in advanced maths in SEBA in class 9. Now, this is not included, this is not a question of arithmetic progression or geometric progression. This is a question of binomial theorem. This is a question of binomial theorem. Binomial theorem. And why I want to just do this is my last question, why I want to introduce here this. For binomial, such type of question divisible by, what will be the remainder? Such type of questions are very important, and it has been found that it is repeatedly asked in JEE Mains. It has been found that it is repeatedly asked in JEE Mains. Such type of questions are very important because in binomial divisible by, such type of question, and it has been found that it has been repeatedly asked last 4 to 5 years. Such type of questions has been repeatedly asked. So here this is a binomial question. So to solve this, here see 21 minus 2, 21 19, 200 plus 21 plus 2, 200. So there is a formula, but you can make this formula yourself: x plus a to the power of n minus x minus a to the power of n. You can make this formula yourself. So instead of expanding both sides, it is better to minimize it. So this is 2 and c naught a to the power of n plus and c2 a to the power of n minus 2 b uh, uh, let this be a plus b and a minus b. So b2 and c4 a to the power of n minus 4 b4, it goes on like this. So now I am going to put the value of a and b here. So this will be 2 200 c naught 21 to the power of 200 plus 200 c2 a 21 to 198 21 21 that is 2 to the power of 2 200 c4 that is 21 to the power of 200 minus 4, that is 196 to 4, and your last term will be 200 c 200 2 to the power of 200. This will be your last term, and before that sorry before that it will be 200 c, this is 200, so 198 198, this will be, because these are even terms, so c 198, this will be 21 to the power of 202 into 2 to the power of 198 plus this. So here we see one thing here, that 21 into 21, this is divisible by 49, because 7 3s are 7 3s are 9. So this is divisible by 41. That means up to this 21 square. So see, up to this term it is divisible by, up to this term it is divisible by here your 49. Up to this term it is divisible by 49. So here you see that up to this 221 square, this is divisible by 41. So the only remaining term left is this. This is not divisible by 49 because there is no 21 square. So your term left will be 200 C 200 2 to the power of 200. So this is 1. So this will be how much? 2 to the power of 201. So here 201 is divisible by 3. 201 is divisible by 3. 3 6 are 18. 2137. So this will be equal to 2 to the power of 3 to the whole power 67. Here this. Now this can be written as 8 to the power of 67. So 8, this can be written as 7 plus 1 to the power of 67. 7 to the power of 67. So now you expand it. 67 C1 7 to the power of 67. 67 C2 7 to the power of 7 minus 2 65. 65. Similarly it will go on and your last term will be 67 C 67 1. Your last term will be this one. Now so here you 1, before this will be 67 C 66 65 7 to the power of 5 2 plus 67 C 66 7 plus 67 C 67 1. So here again we find that up to 7 square, this term is divisible by 49. So the term left is this one. So 67 C 66 7 plus 1. So this will be 67 plus 1. Last term is 1. So this will be 67. Last term is because this terms here it remains this 66 factorial. So yes, this will be 1. So this will be 67 into 7. 7 7s are 49. 7 6 are 42. 42 46. So 469 plus 1. So this will be 470. So here your remainder is how much? 470. 470 is your remainder. So this is an important question. Why this is an important question? For binomial theorem, it has been found that divisibility, test of divisibility is done by binomial theorem. So such type of questions has been asked repeatedly in JEE mains. You can find last 3 or 4 years back, you will find such type of questions are being asked.